7.6. We're talking about double angle and half angle formulas. Finish double angle. Half angle. And the first example is actually very similar to the one we just did, but it's in a different quadrant, so I definitely want to talk about it. It says, suppose cosecant of alpha is negative 13 over 5. For example, cosecant of alpha is negative 13 over 5. And we know the quadrant of alpha. It's between 3 pi over 2 and 2 pi. Find sine 1/2 alpha, cosine 1/2 alpha, tangent 1/2 alpha. So these are all the half angles. So what do you think? What do we need to do?
Get the quadrant first.
Yeah, so let's narrow down our quadrant for alpha. In fact, I'm going to do our quadrant for alpha over 2 as well. Quadrant for alpha, alpha's in quadrant 4, right? Clearly. Since it's between 3 pi over 2 and 2 pi, it's got to be in quadrant 4. What quadrant will alpha over 2 be in, and why? Or 1/2 alpha? What happens if you multiply everything by a half?
3 pi over 4.
So if you hit everything by a half, this guy's going to become 3 pi over 4 right here. This guy's going to become 1/2 alpha. And then this guy's going to become pi. So alpha was in quadrant 4. Where's 1/2 alpha? Quadrant 2. All right, so the half angle is actually in quadrant 2. Let me answer this. This is related, so I'm going to take a brief aside here. Alpha was in quadrant 4, and therefore 1/2 alpha was in quadrant 2. Is that always going to be true? Not necessarily, because, I'll show you a slightly trickier example. If I gave you alpha between, say this is 4 pi and 3.5 pi, so 7 pi over 2. Where would this guy land?
In the same quadrant.
So 4 pi is 2 full revolutions, so this is 4 pi, right? And 7 pi over 2, if you divide the 2 in, this is 3.5 pi. So 3 pi is here, 3.5 pi is here. So alpha lands here in this description. What happens if you hit everything with a half? So you get 7 pi over 4 is less than 1/2 alpha, is less than 2 pi. So what quadrant is that in? 4. Right? You landed in 4 again. Because 2 pi is right here. 7 pi over 4 is down here. So here's alpha over 2. So you can't, I mean, people, I don't know, students just try to basically memorize because they don't understand multiplying by a half. They say, oh, if it's in quadrant 4, it's going to be in quadrant 2 all the time. I will trick you and make it in quadrant 4 and still in quadrant 4 if I feel. So definitely try to get behind what I'm doing here and understand whenever you're working with half angles, to get the quadrant of half alpha, you just multiply everything by half. Now we need to go on. If we're trying to find sine of 1/2 alpha, our formula is plus or minus square root of 1 minus cos alpha over 2. This is the formula. Now, let's go ahead and choose that plus or minus right away. Which one's it going to be? Plus what? Because in quadrant 2, which is where 1/2 alpha is, and in quadrant 2, sign is positive. So choose a plus. Then we have to fill in cos alpha. How do we figure out cos alpha? Draw a triangle for alpha. Right? We have cosecant of alpha, so if we use that information, if we use cosecant of alpha and the fact that alpha is in quadrant 4, we can draw a triangle. This guy is alpha, not alpha over 2. This is the regular angle, not the half angle. So I want to focus on, when I'm drawing this triangle, I want to focus on just the alpha information. My info about alpha. My regular angle. So I'm going to draw alpha in quadrant 4. Right, there's my triangle. Cosecant is the reciprocal of sine. Right? Sine is usually opposite over hypotenuse, so this will be hypotenuse over opposite. Now, am I going to make my hypotenuse negative 13 and then make this side 5? No. Right? The hypotenuse is always positive. And the opposite side should be 5 because, or should be negative 5 because we're in quadrant 4. Pythagorean theorem tells you the remaining side. What's this remaining side? 12. Positive or negative? Positive because it's in the first quadrant. So this is alpha. This is your diagram for alpha. Not alpha over 2. And it tells you cosine of alpha, which is 12 over 13. So you can come back and fill in that missing information now. We have a positive out front, square root of 1 minus. Instead of cosine alpha, we put 12 over 13, all divided by 2. Then you do some simplification. This 1 is going to become a 13 over 13. So 13 over 13 minus 12 over 13. 1 over 13. Oh, but all of that's still over 2, huh? Make that a little smaller. So then that 2 becomes a 2 over 1. Flips up. So root 1 over 26. But you know the square root of 1. Easy rationalize. This is sine of 1/2 alpha. So this is kind of the exact same simplification we just did, so I kind of zoomed through it, but I'll take a drink and give you a chance to absorb it into your skin, preferably into your brain, and into your heart if you like. You're allowed to love the problem. It's okay. What do you think? Oh, I love that, Josh. That's so awesome. Thank you for showing me that.
That actually helped a lot.
Oh, good. See? So, what about cos alpha over, or cos 1/2 alpha? Do you want to do the formula or draw a triangle?
Triangle.
Yes. I didn't want to do the formula. So for cosine 1/2 alpha, you can draw a triangle using sine 1/2 alpha. What quadrant is this triangle going to be in? 2, right? Because we're doing cosine of 1/2 alpha now. We're not doing cosine of regular alpha. So if you want to draw a triangle, you have to use quadrant 2. You have to use this information. This guy's the information for 1/2 alpha. So I draw a triangle in quadrant 2, like so. This is my 1/2 alpha. How am I going to label my sides? But opposite is root 26. And hypotenuse is 26. So you have to do the Pythagorean theorem. A squared plus root 26 squared equals 26 squared. Anybody want to help me out? What'd you get? Root 650. Does that simplify?
Root 26.
Yeah, because there's going to be a 25 in here, right? 25 definitely goes into 650. 26 times, so this will be 5 root 26. Negative or positive? Negative because we're in the second quadrant. So then you can read off both cos alpha over 2, or 1/2 alpha, cos 1/2 alpha, and tan 1/2 alpha. Cos 1/2 alpha will equal adjacent over hypotenuse, so negative 5 root 26 over 26. And tan 1/2 alpha will equal opposite over adjacent. Negative root 26 is opposite, adjacent is negative 5 root 26. So altogether this last one will be negative 1. So once you get your foot in the door, then you can draw a triangle to get the other piece of information. Just make sure you put it in the right quadrant. 1/2 alpha. Okay, questions?
No.
No? Oh, cool. All right. Example. So I have one more half-angle example, and then we'll do some identities. This guy says use a half-angle formula to evaluate cosine of 157.5. So this is degrees. I've stooped to degrees. So what do you think?
Double the angle.
So if you want to use a half-angle formula, right, that's what it says, then we want to write this as cosine of 1/2 of something. Right? If we can recognize this as 1/2 of something else, then we can apply our formula. So the first thing to do is rewrite this as cosine of 1/2 times some angle. So what do you take half of to get 157.5? Or, yeah.
315.
315. And how'd you get that?
Doubled it.
You double it. If you double this guy, then you can put the half in front and it'll equal out. So the way to calculate cosine of 157.5 is to realize that this is half of a special angle. It's half of 315. So then we can use our formula, which says cosine 1/2 alpha is plus or minus 1 minus or plus plus alpha over 2. So now I can apply this formula because I have it where alpha is equal to 315.
So this will replace like our little sum and difference formulas when we try to get like a 15 degree, you know.
Yeah, you can use a half angle formula to do 15 degrees as well. Instead, or some difference, you can do either one. Yeah, but this is a new angle that we've never been able to, even with double or with angle addition and angle subtraction, we haven't been able to calculate cosine of 167.5. So this is just a new angle we know the cosine of. So what am I going to write? What's this equal to? How do I apply the formula here? Equals plus or minus square root of 1 plus. So then what am I going to put in for cosine alpha?
315.
Cos 315. Over 2. This is my alpha. But this is completely calculable, right? I know I can figure out what cosine 315 is, so I can actually do this out here. Before that, let me pick the plus or minus. Am I going to pick positive or negative here and why?
Positive.
Positive makes me sad. Try again. So this plus or minus depends on the angle that you're trying to calculate cosine for. This original angle, this alpha over 2. So what quadrant is this in? 2. 2. Is cosine positive or negative in quadrant 2? Negative. So this is the half angle. This is what the positive or negative comes down to. The original angle, right, without the half in front, that's in quadrant 4, but I don't care about that yet. This guy is what tells you this sign. Cosine is negative in quadrant 2. So I apply my formula, I pick my sign, and now I do any, I actually have to calculate this cosine here. So 315 lands in the fourth quadrant, right?
Mm-hmm.
So what's my cosine value at that angle? 2 over 2. So at 315, I know I have a root 2 over 2, root 2 over 2 with a negative like this. So then up here, I'm going to put 1 plus root 2 over 2 divided by 2. So I replace this with this. But this is ugly, so I will try to make it less ugly. Try my best. So how can I simplify this a little bit? Let's go ahead and add these fractions. Right, this is a 2 over 2. So if I add 2 over 2 plus root 2 over 2, what do I get? Root 2 plus 2 over 2. But I have another over 2. This first 2 came from these guys. But I still had another 2 right here. So now I can flip and multiply. But if you flip the 2 over 1 up, and it becomes a 1/2. You'll do 2 on the bottom times 1/2 up here. Will be 4 on the bottom altogether. Do you know the square root of 4? Well, I know the square root of 4. This would be the final simplified answer for cosine of 157.5 degrees. Not that I don't think you should be able to do this. I do think you should be able to do this. I pray, I hope that you are able to do this, especially if you're moving on to calculus. But I don't have the patience to grade you doing this if you don't know how to do it, because it just makes me sad. So pretty much on a test or a quiz, at least on a test, if you can get to here, I'm pretty happy. All right, I'll probably give you full credit for that. Why here? What's so special about this step? Yeah, all the trig is done. Right? You picked your sine, you found cosine of 315, you've done all the trig. Right? Now, the rest of it is just 96 actually. Right? This is just intermediate algebra stuff. So, if you can get here, I'm pretty happy. Of course, if you want to try to match the answer in the book, you gotta do it. And if it's multiple choice, then you might have to do it. Say, you trig students. We have nothing to say for ourselves. We're good, good, excellent. It's my deputy then. That makes everybody happy. We're fine at that. So that 2 for you. Oh, fun. Sine squared theta over 2 is supposed to equal secant theta minus 1 over 2 secant theta. All right. Good. Good. Feel good about this. How do we start? Right side? You want to start here? You don't want to start here. You want to start here. Why do you want to start here? Well, the square too, but you have a formula for sine theta over 2. Right? You have a nice formula that you can just plug right in for sine theta over 2. Get you well on your way. So, if you look at your formula here, I guess I can just write it out. I know that sine theta over 2 is equal to, so that's this formula, 1/2 alpha, think of that as a theta over 2, then this will become cos theta over 2. You can really go either way. If you really wanted to start on this side, it wouldn't hurt you. Okay? But at the end of the day, you're either going to have to use this identity to go this way or to go this way. So if you start on the right side, then you're going to have to apply the identity this way. And if you start on the left side, you'll apply the identity this way. So it's just up to you which one seems easier. I like going this way. So let's try starting on the left. How is this squared going to affect things?
You have 2 per.
So you have a formula for sine theta over 2, and the square just means take that formula and square it. Right? So this is, you think of this like it's on the outside, it's kind of like this. You just take whatever sine theta over 2 is and square it. That's what this means. So you write plus or minus square root of 1 minus cos theta over 2. But then because it's sine squared, you have to square it. So this is just our half angle. Bueno. Now what does that square accomplish? Yeah, if you have a square root being squared, they cancel each other out. And the same with the plus or minus, if you square a plus or if you square a minus, you get plus again, right? So the square is going to get rid of this and the square root. Okay, this is where it gets tricky. So far we just plugged in the half angle formula and then canceled the square and square root. But now we have to think a little bit. We're trying to get to secant theta minus 1 on top and 2 secant theta on bottom. I mean, I know what to do, but I don't know how to get you to see what to do. One thing you want to notice is that this 2 and this 2 match. So that's good. That's a good start. On the top, secant theta minus 1 versus 1 minus cos theta, they actually differ by a factor. If I multiply this by the right quantity, I will get this.
Should you multiply by 1?
Yeah, so what kind of one?
Maybe a cosine.
So, how does the denominator differ from the denominator here? What's it missing?
Secant.
Okay, so me being just very pushy, I'm going to simply put a secant theta in the denominator. I'm saying I want it there, I'm going to put it there. That's what you get, fraction. But I can't just do that, right? The laws of the universe say I need to put it on top as well. So I do secant theta on top as well. That doesn't change anything because I multiplied by 1. But it will allow me to get the denominator perfect. And then I can hope, I can pray, whatever being or non-being I believe in, that the top works out okay. So what happens when you distribute the secant here? What's secant theta times 1? Secant theta, okay, cool. And then cosine theta times secant theta.
1.
You know what that is?
1.
1. Why?
Because the cosines cancel.
Yeah, these are reciprocals. This is cos, this is 1 over cos. Cos times 1 over cos is just 1. So altogether you have secant theta minus 1 over 2 secant theta. The elusive check mark. Sometimes this comes up. I wish I had great advice on how you can recognize this. I don't. I really don't.
Just trying to figure out what you need to do to make the bottom match the...
Yeah, so kind of the trick I use in my head is that the bottom matches exactly if I multiply by secant, and then I hope that it works out okay on top. If it does, it does. If it doesn't, erase it and try something else. Good advice, huh?
Hope for the best.
So I hope for the best. Prepare for the worst. Hope for the best. Questions? Try another one. You're not going to like the next one. Tangents and cotangents. You like it?
Good check.
Check. It's obviously true. Any idiot can tell me this is verified.
Good to go. Why is there suddenly an oh, no. And I was
Yeah.
reading alphas and I was like, what?
Yeah, I changed my angle to X just to keep you on your toes.
It's really close to fix. Alpha, really close.
Yeah, it's kind of close, huh? Missing a little loop. Okay. What do you think? So there's kind of two problems, the way I see it, with this identity right now. One problem is that you have two things being added here and you only have one thing here. Right, so you're going to want to find a common denominator and add these. At least that's my intuition. The other problem is the angles don't match. Right? This has a half angle and this has a full angle. So I'm going to have to take care of that as well. I'm slightly reluctant to use the half angle formula for tangents because the one that we have so far is kind of ugly and has a square root in it. And so that's not going to get me any closer to where I want to be. So I'm going to start by adding these together and just see what happens. All right, I'm going to take tan 1/2 x plus cotan 1/2 x. And I'm going to write them as sine over cosine and try to add them together and see if I can get anything decent. So tangent 1/2 x is going to be sine 1/2 x over cosine 1/2 x. Cotangent is going to be the opposite, or the reciprocal, cosine 1/2 x over sine 1/2 x. And then how would I combine these to one fraction in hopes to get two cosecants? Common denominator. So this guy on the left needs sine. Right? So I put in a sine 1/2 x. Sine 1/2 x. This guy on the right needs cosine. So what happens here? This guy gives you sine squared, 1/2 x. This guy gives you cos squared. Oh, that makes me happy. Yes, yes. There's a ray of sunshine in this storm. What happened to the top? It's 1, right? Sine squared plus cos squared is 1. Come back down. Does it matter that it's 1/2 x here? Put in sine squared plus cos squared? No, you can put anything in here as long as it matches. Right? Sine squared of goat plus cos squared of goat will be 1. Right? As long as these match. Okay. Now here's where it gets a little hairy, I guess. You can use the half angle, maybe you can probably use the half angle formulas here. I wouldn't, just because they're going to give you square roots and there's fractions and it's going to make your life a little bit annoying. You can. But you can also use the double angle formula here. Do you remember the double angle formula for sine? What does sine of 2 theta equal? sine 2 theta equals
2
sine
sine.
theta cosine. So this is floating around in your head somewhere, floating around in my head, floating around in your book. So sine 1/2 x, cos 1/2 x almost fits this format. Except that instead of theta, I have 1/2 x. That's okay. That's perfectly fine. I just replace this theta with a 1/2 x. Beautiful. But the 2 isn't there. That makes me more sad. I need the 2 to apply the formula. So how do I force the 2 down here? Multiply top and bottom. Right? You don't like something? Fine. Here. Boom. Done. Man, that's how man deals with his problems. There's a 2 there, you just put it in there. So then on the top I have 2. What does the bottom become? Sine of 2 times 1/2 x. Right? Because I have 2 sine 1/2 x cos 1/2 x. So you look at the other side and that becomes sine of 2 times 1/2 x. Two times 1/2 is 1. Check.
You lost me, I'm sorry.
I know.
Where does the cosine go?
Yeah, that's right. Ah, I see it.
So in the formula for sine 2 theta, there is both a sine and a cosine. So the cosine gets absorbed into this sine 2 theta. Right, so I was able to replace this as long as I put this 2 here.
Can you write it out?
I'm going to throw it out right here.
I know, that is,
Okay, so sine 2 theta equals 2 sine theta cos theta. Right? But I don't have theta, I have 1/2 x.
right.
So 2 sine 1/2 x cos 1/2 x should equal what? So this is what this is here.
So you just added a 2, you didn't pop 2 in, okay, I see it now.
I replaced it using this format,
Okay.
using the double angle.
Yes.
It's tricky. I purposely picked 2 kind of tricky identities, just, I don't know, just so you don't complain. I never saw that. So hard. There are, down at the bottom, there are multiple forms of the tangent half angle formula. There's 3 different forms. I'll give you all 3 on a test, right on the final. I'll write all 3 of them down for you. These 2 forms are a little bit nicer only because they don't have square roots, right? So you don't have to choose a plus or minus. So when you're dealing with tangent of a half angle, you don't want to use those. Whatever, it's just a number set. So, that kind of concludes my half angle discussion. We have, supposedly in chapter 7, we have 1 more section to cover. We're supposed to cover sum to product formulas. Whatever, and product to sum formulas. Whatever. I don't know. I mean, if you need these, you're going to look them up and use them.
It's the same thing as the sum and difference, except you pull out.
Yeah, you take the sum and difference and like you add them together and you get these. I mean, they're useful every now and then in obscure cases, but they're not nearly as useful as like the double angle formula. So I'm just going to say, here's a set of formulas. I probably assigned you a couple homework problems, try them. But as far as our class goes, I won't test you on. Okay? if you can plug in alpha and beta in every other formula that we've done, then you can plug in alpha and beta here. There's nothing new.
Would that be an extra credit?
No,
Okay.
no, I mean, no. I don't even care about them enough to make you,
Okay.
to give you extra credit for them. They're not.